Hello, welcome everyone to session 2 of the UFAW virtual conference, Recent Advances in Animal Welfare Science 7, our first ever virtual conference. My name is Stephen Wickens, and we will be beginning the talks fairly soon. Based on the first session, which I hope a number of you watched, there is a little bit of a lag when people join. So this is why I've started the webinar a little early and just waiting for people to come through. As I said at the beginning of session 1, this is now the second of 5 sessions we'll be broadcasting over the next 2 days. The sessions are being recorded, and those recordings will be made available on a web page, which we'll share the link with you later, probably within about 24 hours. But to watch each of the sessions live, you'll need to have registered for each session using the link we previously shared with you via email. As you've seen from this morning, the conference features live talks from a great range of speakers, and this afternoon too. And hopefully you've got the idea about asking questions, which you can do using the chat question tab in the meeting drop-down menu. We also have an extensive range of diverse, exciting, and innovative science presented in the conference posters. Some of you are having problems accessing the posters via the handout that's also in the drop-down menu. However, if you use the Dropbox link in the original email that was sent to you when you were reminded to join the webinar, and go to that Dropbox, you'll then find there's a document there where you can click on a relevant link to take you to the poster. If you've got any questions for poster presenters, then can I ask that you please contact them directly using the email shown in the abstract booklet. There are other handouts you can access via the drop-down menu, including a code to get money off the UFAW Wiley Blackwell series and a certificate of attendance for the conference. All of these can be downloaded, but you can only download them while the session's going on. So if you want a certificate of attendance, I suggest that you do that before the session ends. So, as I said, this is the first of such meetings we've run online. I said at the beginning of session 1, we've learned a lot and we'll learn more, and we did learn further during session 1. One of the things we learned is that if you're trying to watch the videos using Safari, a Safari browser, you may have more problems than if you actually open it via Chrome. So people who open it via Chrome, it seemed to be much better. There were some audio issues too, and I think that that's what you'll need to do is to actually check where the audio is coming out, because if you're using a set of headphones, you may not have switched it to that so you can hear when the videos are on. So that has given time for people to join us for the second session. And without more ado, we're going to start with the first speaker of session 2, which is Mariann Molnar from the Central European University in Hungary. And she's going to be talking about producer perspectives on farm animal welfare and the intensification of farming in Hungary.
Good afternoon. I will be talking about producer perspectives on farm animal welfare during the intensification of farming in Hungary, a PhD research project that I carried out at the Central European University with the help of Professor David Fraser from the University of British Columbia. The talk is based on 2 publications, one that is already available and one that we hope will be coming out soon. The references will be indicated at the bottom of each slide showing the data. History tells us that to pursue a successful reform process, it is essential to clearly conceptualize the ethical basis and the overall goal of reform efforts. And a study by Anderson suggests that in the case of child labor, reformers relied heavily on legislative and market-based arguments to liberate children from mines and factories. In the current farm animal welfare reform effort, there is wide agreement that complex, interconnected factors affect farm animal welfare conditions. Scientific data also indicate that farmers and the general public appear to have conflicting norms, that there are inconsistencies between societal principles and consumer purchasing behaviors, and that the uniform enforcement of existing legislative standards is often problematic. but few data are available on how legislative and economic constraints impact the perceptions of farmers and how the norms of farmers differ depending on the farming methods they embrace. So the aim of the study was to understand the perceptions of animal producers of external pressures and how they influence farming operations and animal welfare, and also to conceptualize the views of animal producers on animal welfare and ethical animal production, and how the different systems require different means of supporting improvement. Most previous research on animal welfare involving farmers as participants has occurred in Western Europe and the English-speaking countries, where the shift to confinement production is far advanced. Hungary presents a valuable study opportunity because it still has a mixture of emerging intensified systems plus a resurgence of non-confinement systems and is part of the EU regulatory framework. Farmers' perceptions were explored in 24 in-depth semi-structured interviews with Hungarian confinement and alternative pig farmers. Participants were identified using a snowball sampling method until data saturation. Interview data was transcribed verbatim and analyzed with the help of the Atlas TI software. The research used a purposive sample of participants who were residents of Hungary and kept 50 or more breeding sows for commercial purposes. Confinement farmers were identified as those who kept domestic pigs of modern white breeds in indoor housing with mechanical ventilation and automated feeding and watering systems. On the other hand, alternative farmers kept Hungarian Mongolica pigs, white breeds or wild boar that were housed predominantly outdoors with manual labor for tasks such as feeding and cleaning. Participants were also expected to operate farms that conformed to agricultural and animal welfare legislation to ensure that they were representative of mainstream farming communities. Much previous research emphasized the differences in values between animal producers using confinement versus alternative or organic systems. Our findings indicate that there was considerable agreement between the views of confinement and alternative farmers on what constitutes good animal welfare, and participants believed that small-scale, low-intensity, near-natural farming systems and good husbandry practices provided the best possible conditions for farm animals. And on the first quote, a confinement farmer claims that animals are not kept by anyone who does not love them. If you love an animal, you will not cause unnecessary suffering. You will keep it according to its needs. So the second quote is by an alternative farmer who said that I once had a beautiful bull which I had to sell to a slaughterhouse. On arrival to the plant, the bull fell over and was unable to stand up. Slaughterhouse workers started to beat my bull, and I shouted, "What on earth are you doing?" But they told me to mind my own business. The deal was done, I had my money, and they told me to leave. So I did, but I cried. So in terms of core values, we have found that emotions were very important and farmers had a high level of attachment to their animals. Alternative farmers consistently applied their core values when producing for the market or for their own consumption. Small to medium-scale confinement producers, who had around 400 sow operations, generally raised a few pigs under traditional conditions for their own consumption. And the quote says, "Any animal derivatives that I consume will come from an ideal, near-natural rearing system," illustrating that point. This finding emerged during the fourth interview, and all remaining 7 medium-scale participants claimed that they kept pigs for personal consumption in different conditions. It was only the largest producers with herds of 1,000 sows and above that used confinement-bred pigs for their own families. The following quote illustrates this point. "My wife does not want to hassle with pig slaughter, processing and freezing. It's perfect for her if the food is half done, assuming that in the professional processing plant, the frozen hamburger really does not contain any anthrax." Findings show that the values specific to confinement systems are found to represent the immediate concerns of farmers rather than their true ethical principles. Results also indicate that farmers are vulnerable to economic pressures, which make it very difficult in confinement farming systems to put positive animal care values into practice. The first quote shows this. Confinement farmer claimed that the sector is profit-oriented, but since 2008, the market reached a record low in prices, and we, the farmers, had to produce below production cost and could not realize any profit. Farmers used up all of their reserves. But if there is no money in the sector, then we are unable to ensure good welfare. Economic pressure can also lead to short-term thinking and induce production externalities along the whole value chain. And this is showed in the next quote. We wanted to use manure on our lands, but it required a huge effort. We could accomplish about 20 hectares a day, while 80 to 100 hectares can be done with spreading artificial fertilizers. We know that in the long term, artificial fertilizers will harm the natural environment, but people also need what is here today. Confinement farmers also reported technological lock-in, whereby large investment in facilities prevented them from making major changes in production methods. And the following quote shows this. The economics of a farm depends on the building structure, the economic structure, specific production parameters in the market. It is difficult for us to change the building structure and impossible for us to change the market. We are left with the only possibility to fine-tune the economic structure of the farm by decreasing input costs. So early technological choices seem to be self-reinforcing. Once a farmer invested heavily in automation and facilities, they saw little option except to continue using these technologies. But a pressure to reduce input costs, including welfare-related amenities, was perceived as an inescapable reality of the market. Alternative farmers sell into niche markets, use inexpensive technologies, and typically produce a diversity of agricultural products which buffer periods of low profit in any one commodity. And the following quote illustrates this. From the start, I built a system that was not dependent on one leg. There came a crisis in the pig market, which would have eliminated us. After that, there was severe drought. If I only had grain, we would have gone bankrupt that year. So we tried to balance things out. When we had 20 sows, we were able to farm 30 hectares of land, and every leg had to be of the same scale and grow evenly. So I must emphasize that balance and diversity are crucial. Findings indicate that while alternative farmers have higher variable costs of production due to slower growth rate, lower feed conversion efficiency, they were economically more resilient because they avoided the economic pressures of the mainstream market. Regulations focus mostly on inputs such as the physical environment and certain management actions, and were seen by participants to mitigate some negative features of confinement production methods without leading to major reforms, which is illustrated in the next quote. Standardized legislation only provides a framework, but it does not take us very far. Approaching animal welfare by giving a list of physical and some vague management-related rules will not ensure that livestock will be properly cared for. Regulations also appeared to be designed for confinement systems and seemed to make a poor fit for alternative systems. The next quote shows this. Ministry officials came and checked the premises and found 1.5 centimeters difference between the legislative standards and our fence and ordered us to take it down immediately. But the fence did not make any difference to welfare. While farmers believe that animal welfare payments created a win-win arrangement for producers and farm animals, most common agricultural policy payments were seen to help confinement farmers stay in business when product prices were low, and were only able to compensate farmers for higher welfare conditions when prices were above the cost of production. And the following quote illustrates this. In the current harsh market conditions, it is possible to break even with the sow welfare payments. That's all. Subsidies were also seen to reward farmers providing more space in confinement units, while giving no rewards for the more spacious environments in alternative systems unless farmers use loopholes to qualify. The following quote reads, "We could hardly get sow welfare payments. Our application reached the highest possible forum, and they said to us, why should we give the Mongolitsa farm any money? The pigs have such a good place anyway." We finally managed to resolve the issue, but we needed to find a loophole in the legislation. So findings indicate that the official tools intended to protect welfare, both regulations and subsidies, are mostly applicable to confinement systems, but do nothing to support other systems where welfare is arguably better. So to conclude, our data suggests that a successful livestock welfare reform will depend on, first of all, extending current problem-solving approaches to incorporate external factors such as economic pressures. Second, a regulatory system that is developed with greater consultation with producers. And third, incentives to encourage farmers to act on their core values. And with this, I would like to thank you very much for your attention and acknowledge that this work was primarily funded by the Central European University and generously supported by Professor David Fraser and funded by the Central European University and generally supported by Professor David Fraser and the
Thank you for that. Sorry, somebody had turned their microphone on who was still listening to video, which is why we got the feedback, but I've just turned them off. So thank you very much, Mariann.
Thank you.
We're now available for questions. So first one we've got through, which you can ask via the drop-down chat box. It said, how did you choose your 24 interview partners? Are they based in different regions of Hungary? How old are they, and what type of education, etc.?
That's a very good question. Thank you very much. So I identified the participants using a snowball sampling method. So I only needed to identify the first participant, which was who was recommended to me. And from that point onwards, the participants recommended each other. So the moment I finished the interview, I asked my participants whether they could recommend any other farmer to visit who would be important to talk to, and they gave me the contacts. In terms of education, so I had 24 participants in this study, half of which were alternative farmers and half of which were confinement farmers. And most of them had higher education degrees. So most of them were veterinarians or they had agricultural degrees. So 22 had higher educational degrees and 2 had only secondary, but they were relevant for animal farming because they were either agronomers or had other animal breeding or other relevant educational backgrounds. And in terms of locations, I showed the map. So basically, I traveled around Hungary, so they were my participants were quite dispersed.
Another question: did any of your participants have a history of alternative farming before going to confinement, and were there any differences in those farmers' opinions?
That's a very good question. Yes, a lot of them who were older, especially who were older, they grew up in farming families and so remembered that their grandfathers and their fathers kept pigs in a completely different system. And so their opinions were somewhat different, but all in all, they were not significantly different because, and this was an important finding in the study that confinement farmers were actually quite connected to their pigs, even if they started off with a confinement farming system. And early technological decisions were actually very relevant in their perceptions.
Another question that's come in says, did you see an ethical dilemma on animal farming as such in farmers belonging to either of the groups?
Well, ethical dilemma, this study was all about ethical dilemmas, and I think the answer is yes. Of course, there were many ethical dilemmas, and obviously we can't generalize. We can't say one system was better than the other. We found that actually husbandry and the quality of farming was very, very important when it came to the professionality of the farmer. So a good farmer could compensate some of the weaknesses of technology and vice versa. Even in a good system, if the farmer wasn't 100% competent, then things could have gone wrong or could go wrong very easily. But so in terms of ethical dilemmas, there were many to address, but we very much focused on the ethical dilemmas connected to the systems they were involved in.
Thank you. Do we have any more questions that anyone wants to send through? I'll just pause there. Thank you for a very interesting presentation. This is Carol Gray. Did the farmers who were confinement farmers yet reared alternative pigs for their own consumption admit to having double standards? Would they have liked to rear all pigs in their alternative methods?
Yes, absolutely. This was a very important finding, and we saw a difference in terms of scale. So those farmers who kept pigs in confinement systems, who had smaller scale establishments, around 400 sow operations, they all claim that they kept pigs for their own consumption differently. And they emphasize that obviously in an ideal scenario, they would keep all of their pigs like that, but it just wasn't possible due to economic pressures. Now, once we got to the point where 1,000 sows were kept by the farmer, then their perceptions changed a little bit, and they were less skeptical about the slaughter and meat trade. They were less skeptical about processing, and they were less skeptical about farming systems or their own farming system. So they had more trust in confinement methods and large-scale operations.
So Sarah Heaney asks, is this work going to try to influence farming in Hungary? And she
well,
said,
of
sorry,
course, I will. Yes.
If you mentioned this already.
Apologies, can you repeat the question, please?
Yeah, sorry. Yeah, Sarah said, is this work going to try to influence farming in Hungary? Sorry, I missed the end of the presentation if you mentioned it already.
Oh, thank you. So yes, of course. Well, the first thing is to publish the results, and obviously I'm trying to give as many talks as possible and to go back to. I actually keep in touch with the farmers. Some of them are very active and they want to keep in touch and they want to take it further. But we're still seeking answers how to change these processes and how to influence their decisions and the market and the context they have to farm in.
Thank you.
Thank you, Mariann.
There are no more questions. Just wait a minute.
Thank you.
Well, thank you. Thank you very much, Mariann. So what we now do is we'll move on to the next presentation. Goodbye. Next presentation is from Elena Armstrong from Newcastle University. She's talking about adult hippocampal neurogenesis as a marker of cumulative experience in laying hens. Now, I should warn you, the sound on this is a little tinny, but hopefully it's loud enough so you should be able to hear it. Okay, so I'll play that now.
Hi, I'm going to be talking about the most interesting findings from my PhD project, which was kindly funded by UFAW and which explored the use of adult hippocampal neurogenesis as a marker of long-term experience in laying hens. So neurons are specialised cells of the brain and central nervous system which transmit information in the form of electrical impulses. Only a few regions of the mammalian forebrain continue to produce new neurons for the adult lifespan, and one of the main areas where this happens is the hippocampus. In a process known as adult hippocampal neurogenesis, stem cells continue to divide throughout adulthood, and a portion of these differentiate into specialised neurons, which are then integrated into the existing brain circuitry and exert functional effects. So the hippocampus seemed like a promising place to look for a neural marker of animal welfare because it is sensitive to experiences across multiple species. Long-term experiences modulate levels of adult neurogenesis in a directional manner depending on their valence. In other words, the number of new neurons produced is increased by positive experiences and decreased by negative experiences. In humans, the only species who can self-report their feelings, adult neurogenesis is decreased in cases of major depressive disorder, but increased or restored following antidepressant treatment. In rodents, adult neurogenesis is upregulated by antidepressant treatment, voluntary exercise, environmental enrichment and learning, but downregulated in models of chronic stress, depression and chronic pain. Less studies have been conducted in the birds as I was starting the project, but adult neurogenesis was known to be regulated by the experience of storing and retrieving food caches in hoarding species, which involves the use of spatial memory, and to be downregulated by the stress of transitions to captivity for wild-caught birds. Therefore, our research group aimed to address whether neurogenesis in birds, and specifically in laying hens, is similarly reduced by other forms of chronic stress and by chronic pain. The mammalian hippocampus, highlighted in purple in the mouse brain, has two functional subdivisions. The dorsal subregion is mainly involved in cognition and spatial memory, while the ventral subregion is more heavily involved in emotional processing and regulation of the stress response. Reductions in adult neurogenesis following chronic stress are sometimes more pronounced in the ventral region, though they can affect the whole hippocampus depending on the nature of the stressor. The avian hippocampus has quite a different structure, so this is a chicken brain, and if we look at the hippocampus in coronal sections, the rostral region towards the front of the brain is highlighted in the blue circle there, while the caudal hippocampus curves around the back of the forebrain in quite a big section. It's highlighted there in orange. Neuroanatomy suggests that the caudal avian hippocampus is homologous to the ventral rodent region and thus might play a greater role in emotional regulation and responses to stress. Indeed, research in pigeons demonstrates that stimulation of the caudal hippocampus leads to greater suppression of corticosterone release than stimulation of more rostral sides. I have therefore analysed neurogenesis in the two regions separately throughout my project to explore the prediction that neurogenesis in the caudal hippocampus may better reflect stressful experience. The concept was supported by a study conducted in our lab, mainly by Fabio Gualtieri, which involved exposing laying hens to a sequence of mild but unpredictable stressors over an 8-week period. This experience resulted in a reduction of hippocampal neurogenesis compared to control birds, which specifically affected the caudal subregion, shown by the bars on the right. If you are interested in reading more about this study, it is published in Scientific Reports, and that's the reference there. But really importantly, it's suggested experimentally that neurogenesis in chickens is indeed more sensitive to chronic stress. So my research aimed to take the next step of applying this marker to industrially relevant conditions. So the first study I'm going to talk about involved fractures to the keel bone, which is highlighted there in blue. Keel bone fractures occur naturally throughout the production cycle due to collisions with elements of the housing system, such as perches, and they are highly prevalent in flocks, but also individually variable. The arrows on these photographs indicate areas of damage, which lead to deviations in the curve of the bone, and also healed fractures are visible as ridges across its surface. Behavioural evidence suggests the fractures are painful to birds. Birds with fractures are slower to fly down from a raised perch to obtain a food reward, and they also develop a preference for the place they were given painkillers, which suggests removal of this pain is rewarding. Evidence also suggests that fractures take at least a few weeks to heal and are uncomfortable during this period. So we therefore wanted to ascertain whether the pain or discomfort arising from keel fractures is sufficient to present a source of chronic stress for laying hens and thus cause a reduction in hippocampal neurogenesis. So for this study, we worked with collaborators at the University of Bern, led by Mike Toscano and Christina Rufner. Hens were housed in a commercial multi-tier aviary, and 11 x-rays were taken at regular intervals over their adult lives and used to score the severity of naturally occurring keel fractures on a scale of 1 to 10, where 10 was the worst. So here are some example radiographs ranging from no fractures on the left to severe fracture on the right. Again, the arrows indicate areas of damage. And individual mobility data was also collected as an infrared tracking system recorded vertical transitions the birds made between aviary zones, the positions of the transmitters indicated on this photograph, and this occurred for the 6 days preceding each x-ray, so also over 11 time points. As we know, exercise regulates neurogenesis in other species. It was important that we could account for a potential effect of activity on the number of new neurons in our hens. So we aim to sample from both extremes of fracture severity based on preliminary analysis of most of the x-rays, and we ended up taking brains from 9 birds who formed the minimal fracture group with a mean score of around 4, and 15 birds who formed the severe fracture group with a mean score around 9 out of 10. This graph compares activity in terms of transitions at the first and final time points for hens in these two groups. Activity did not change between these times for birds with minimal fractures, but birds that had developed severe fractures made fewer transitions at the final time point than they had previously, suggesting that it was painful or uncomfortable for them to move. So after sampling the brains from our focal birds post-mortem, these were divided into 50 micron thick sections with the hippocampus displayed from rostral at the top to caudal at the bottom here. and the sections we used for immunohistochemistry, which we used an antibody against the double coating protein. Double coating is expressed only by immature neurons which are in the process of migrating and differentiating, so it's commonly used as a specific marker of adult neurogenesis. Through a series of specific antibodies binding, cell bodies positive for double coating are stained brown, which allows them to be quantified in serial sections under a microscope. This was done at 100 times magnification for both multipolar and bipolar cells, where the multipolar cells are more mature and have more than 2 projecting branches, while bipolar cells are younger and presumed to be still migrating and have only 2 branches. So the results of the immature cell counts for the 2 fracture groups are presented here. For both the multipolar and bipolar double coating positive cells, we see a strong effect of fracture group, whereby birds with severe fractures have fewer new cells than birds with minimal fractures. For the multipolar neurons, there was also an interaction between fracture group and subregion. So the suppressive effect of severe fractures was stronger in the caudal region, and hence in the minimal fracture group had more multipolar in the caudal than in the rostral hippocampus, but for the severe fracture group there was no subregional difference in neurogenesis. Further, there was a negative correlation between individual fracture severity scores for each bird and the number of new cells present in both hippocampal regions, and an interaction for multipolar cells indicated that this relationship was a bit stronger in the caudal hippocampus, which is represented by the grey dots and the grey regression line. On the other hand, activity levels did not predict immature cell counts, suggesting that pain arising from keelbone fractures was responsible for this relationship, rather than birds with severe fractures simply doing less exercise. Finally, there was an interaction between the time point at which a bird acquired its first fracture and the number of new neurons. So a positive relationship existed between time point of first fracture and number of double coating positive cells in the caudal hippocampus, again indicated by the grey line, whereas the black line for the rostral region is almost flat. So this indicates that hens that acquired fractures earlier and that have therefore been in pain for longer have fewer new neurons at the caudal pole. If you are interested in learning more about this study, it was recently published in Scientific Reports, so do take a look. Generally, we concluded that keelbone fractures are of sufficient detriment to welfare to constitute a source of chronic stress to laying hens, meaning that interventions to reduce damage are likely to have significant benefits for welfare. So the second study I'm going to talk about sought to compare adult neurogenesis in laying hens from 2 different types of commercial housing run on adjacent sites by the same UK production company. These consisted of a multi-tier aviary system with an outdoor range and an enriched colony cage system which housed about 50 birds per cage. We were interested in whether cumulative stressful experience, reflected by neurogenesis levels, differs for birds in these 2 systems. But in addition to comparing housing systems, we also wanted to capture some of the variation present within each system, and so decided to sample hens of good and poor physical condition according to a 2x2 design. Birds were selected by the farm's production manager using feather cover, body weight, and redness of the comb and face as selection criteria. It wasn't possible for us to compare systems on the same site which were housing the exact same strain of hen, so we did sample highline brown hens from one system and H&N hens for another, and it was necessary to control for this. I'll tell you in a moment how we did that. In terms of sampling, we selected a total of 12 birds in good condition and 12 birds in poor condition from each system. For the multi-tier system, we decided to combine good physical condition birds with those choosing to spend time on the range, as we predicted that both of these factors may positively influence welfare. So we took good condition birds directly from the outdoor range and took poor condition birds from the top inside tier. For the colony system, we wanted our sampling to be independent of cage effects. So every bird came from a different cage, but we took a good and a poor condition bird from each row, and also made sure every row height was represented in an inside and an outside column. And for both housing systems, birds were palpated to detect keelbone fractures, and we avoid taking those with damage due to the known effects of this factor on neurogenesis. So, as I said, in order to control for a baseline strain difference in neurogenesis, it was necessary to sample 14-week-old pullets of the 2 different strains directly from a rearing farm. The two strains were both reared in litter floor systems with perches that were basically identical in adjacent barns on the same site, and adult neurogenesis, quantified in the same manner as before, indicated that there was no baseline strain difference in the numbers of differentiating neurons. So we again saw more neurons in the caudal hippocampus in the rostral region, but little difference between highline and H&N, illustrated here for the multipolar cells, but the bipolar cell counts were similar. Conducted the same immunohistochemistry process for the adult hens, and in general there were more immature neurons present in the caudal and the rostral hippocampus again, but there was no effect of Ising system on cell counts. Our exploration in the pellets indicates that it's unlikely that a true effect was obscured by a strain difference, as we didn't see a strain difference. On the other hand, physical condition did predict neurogenesis in the expected direction, as there were fewer immature hippocampal neurons in poor condition hens from both housing systems. This graph shows the density of multipolar neurons, and while the pattern was similar for the bipolar cells, the effect of physical condition there was only a trend. So perhaps surprisingly, housing system did not appear to have a consistent effect on the degree of chronic stress experienced by the laying hens in our sample. On the other hand, it seems that individual differences in chronic stressful experience exist within both types of housing system, and the relationship between physical condition and neurogenesis suggests that condition itself may provide some indication of overall experience, whether this might relate to health, dominant status, access to resources, or other factors. Housing systems that produce a higher proportion of good condition birds may therefore be associated with greater net welfare, which could be explored in future systematic sampling studies. But overall, it seems that adult hippocampal neurogenesis indeed allows comparison of the long-term experience of gruesome laying hens and may highlight factors that are important for welfare, such as keel bone fractures and physical condition. However, it's measured post-mortem, so it's not suitable for assessment of potential acute stresses, and the immunohistochemistry method is time-consuming, which may limit its application. Our research group has also been looking for a molecular marker of adult neurogenesis that could be quantified more rapidly, though we have yet to find one sensitive enough. So thank you very much for listening. I'd like to thank my supervisors, our collaborators in Switzerland, and especially UFAW. Thank you.
Very much, Elena. We're now available for questions. Hello, hi, good to see you.
Hi.
So, if you want to ask some questions, then please use the chat box, and we'll just wait for some to come in. I'm sure we're going to get lots. Okay, so if you need to ask questions, just remind you use the chat box on the side, and you can type them in there so that Elena can answer them. So Hugh, do you have a question for Elena? Oh, okay. So okay, we've got a question from Bjorn Fortman. Sorry, there was a delay in them coming through. Now they're all coming in. Bjorn says, I'm a bit unsure why you excluded the birds with breakages in your comparison between systems. Aren't they relevant in a comparison?
Definitely it is relevant, yes. The reason we did that was because we'd previously just looked specifically at the effect of keel bone fractures and found that there was quite a strong effect. So we didn't really want to have that take over other potential effects of housing system. So we just did it to try and separate the different factors that might matter, but certainly based on our other study, the housing systems that cause more fractures are potentially associated with more stress for the hens. So it's definitely relevant. We just wondered what other factors of the environment might be relevant as well.
Question from David Pritchard. What was the prevalence of good and poor birds in your study between the two systems?
So the way we looked at it, it wasn't really possible to kind of estimate the overall prevalence of those, so we made sure we sampled an equal amount of good and poor condition birds, but to actually kind of estimate this for the whole system, we would have had to sample quite a lot more birds. In the colony system, there were, I think it was like 11 cages deep, 3 columns high over 2 different floors. So we would have needed to kind of sample a lot more of the birds systematically, but we think it would be really interesting to do that in a future study, because we now know that physical condition does reflect neurogenesis. So if we could estimate the relative prevalence of good and poor conditioned birds, that might tell us something about the overall welfare.
Thank you. Question from Penny Hawkins. Do you think there might be a difference in adult hippocampal neurogenesis? Hang on, let's just get down. If you looked at a parameter, if you look at a parameter at a time, e.g. dust bath access, perches, and other things.
Yeah, that would definitely be really interesting and something we'd like to do in future. I guess only things that are really significant for the bird's welfare would be expected to make a difference to neurogenesis if they affect kind of the total amount of stress the hen experiences, but certainly it would be interesting to see if enrichments like dust bathing did do that relative to more barren conditions. So we would like to look at that in future.
Question from Wendy Wench. Is hippocampus neurogenesis a better indicator than body condition, since body conditions seem to be a good indicator of poor welfare and is much easier to observe?
Yeah, so we weren't sure whether body condition would reflect hippocampal neurogenesis, because certainly in rodent studies, neurogenesis gives a kind of more sensitive, detailed measure of long-term experience. But given that we did find it was reflected by body condition, this is something that might be a lot easier and quicker to measure in hens. So based on that, future studies might want to look at body condition in that way. Yeah, there's still quite a lot of other factors that we're not sure whether neurogenesis might give a better, more sensitive measure of experience than kind of observable external factors do.
Question about keelbone fractures. Somebody missed the beginning and said, what was causing the keelbone fractures? Was it the system they were being kept in? And there's a related one saying, were there differences in the prevalence of keelbone fractures between the two systems?
Yeah, so in response to the first question, keelbone fractures arise quite commonly in all types of housing system, and it occurs when birds collide with elements of the housing system. So things like perches, they often land awkwardly and bash the keel on the metal perches, and that leads to damage and deviations. We didn't actually measure relative prevalence in the two housing systems. I think there is some evidence that they're a bit more common in the aviary cage-free systems, as there are more levels the birds can kind of move between and more things they might hurt their keels on. But I think that's quite a broad literature in itself.
Question, is it possible to pull out any effects that factors such as social rank dominance might have played in your data?
In this study, it's difficult. We kind of just wanted to get an overall picture of things that might be important in commercial housing systems. But I think it would be necessary to do something like take videos of the birds' interactions whilst feeding or something like that to be able to then rank dominance and see if that correlated with cell counts. So that might be easier to do in a more controlled experimental setting.
Question from Anna Juffinger. How valence specific is changes in neurogenesis? Does it get down-regulated by negative but upregulated by positive valence experiences?
Yes, that's overwhelmingly what the literature shows in people, in rodents and in birds. So that's why we thought it might be a really useful marker of experience compared to something like glucocorticoid release, which is upregulated by arising experiences, regardless of whether they're positive or negative. Hippocampal neurogenesis allows us to differentiate whether such experiences have positive or negative valence for the animals.
Question from Jason Yee. Is there any evidence that this is HPA mediated, as people like Sapolsky and McEwen have laid out?
Yeah, so there are studies showing that glucocorticoids do regulate adult hippocampal neurogenesis in response to stress. So if you adrenalectomize mice, for example, then you don't see chronic stress-driven downregulations in neurogenesis, and you don't see upregulation for enrichment. So it certainly is related to the HPA axis, but it seems to be something else which reflects kind of the effect of valence on neurogenesis, because cort, as I said, is upregulated by arousal.
Question from Edward Narana. Is it possible to reverse hippocampal neurogenesis reduction with improved management of birds?
Yes, definitely. So another reason we thought it might be a good welfare marker is that research in rodents shows that it kind of integrates sequential experiences that are positive and negative. So if you expose mice to stress and then move them to enriched housing or provide them with exercise as a positive experience, then the neurogenesis levels come back up. If it's for a short amount of time, they might be intermediate to either stress or enrichment alone, but then long-term positive experience allows them to be restored, as does antidepressant treatment, and opportunities for cognitive stimulation in birds. So yeah, this method would also let us kind of assess whether interventions to improve welfare had that effect.
Excellent. So I think you've answered all the questions. Thank you very much, Elena.
Thank you.
Clearly, if you want to send any more to her, her email is associated with her abstract in the abstract booklet. So
yeah, please do.
Thank you.
Thank you.
Thank you very much. So we'll now move on to the next presentation, which is Sanne Roelofs from the University of Pennsylvania in the USA. And she's going to be talking about measuring judgment bias in group-housed sows.
Hello everyone, my name is Sanne and I'm very happy to share with you today this virtual version of my talk about judgment bias in pigs. So the work that I'll be presenting to you is part of an overarching project I did at the University of Pennsylvania. And the main focus of this project was the welfare of breeding sows housed in groups. So I wanted to start with a little bit of background as to why we want to measure the welfare of group-housed sows. So group housing of breeding sows is becoming more and more common on commercial pig farms as a way of improving animal welfare. Pigs are incredibly social animals, and under natural conditions, they spend their lives living in groups which are organized by dominance hierarchies. Therefore, keeping sows in groups allows them to express a whole range of natural behaviors. However, life in a group can be a complex influence on animal welfare, with differential effects on individuals with different positions in the hierarchy. For example, a sow at the top of the social rank may have very different experiences from a sow at the bottom. So an increased understanding of how to measure welfare in a group setting is very relevant. Now, judgment bias has been proposed as a cognitive measure of animal welfare, which allows for assessment of both positive and negative emotional states. It describes decision-making under ambiguity, where the interpretation of supposed neutral information is affected by an individual's current emotional state. Simply put, judgment bias is responsible for whether you view the glass as half full or half empty, where a positive emotional state will result in an optimistic interpretation, and a negative emotional state will do the opposite. While external conditions can influence judgment bias, It is also very possible for animals experiencing identical housing conditions to differ in their emotional state and their resulting judgment bias. For example, factors such as personality, previous experiences, and also individual social conditions can all play a role. Now, while judgment bias tasks have been widely applied across a range of species, there are some potential limitations to their suitability for animal welfare assessment. For example, judgment bias testing requires a period of discrimination training, which can be quite extensive. Now, most studies report only on the final phase of training, omitting information on any required previous training steps or any necessary habituation. However, even this final step of training can be quite time-consuming, as shown here in some examples. Extensive training requirements not only limit the ease of data collection, they can also result in learner bias, where only the welfare of animals that are able to complete training can be assessed. Therefore, transparency about the training phase of judgment bias tasks is incredibly valuable. The main aim of our study was to successfully measure judgment bias in group house sows. We based our task design on a previous study by Hens and colleagues, who described a judgment bias task that was applied to multiple species, including horses. So we figured, if a horse could do it, the sows should also stand a chance. We wanted to also focus particularly on the ease and duration of training prior to judgment bias assessment, with the goal there being avoiding learner bias and ensuring practical feasibility of our task. Additionally, I will be discussing some results relating to one of the aims of the overarching project this study was part of, which was to investigate social rank as a potential confounding factor for judgment bias tasks. Our research question there was, as pigs maintain strict dominance hierarchies, could an individual's position in the hierarchy affect the outcomes of judgment bias tasks? So that brings me to our judgment bias task, a very basic overview of which you can see here. So the essentials of any judgment bias task is really getting an animal to consistently perform different behavioral responses to one stimulus signaling a positive outcome and another stimulus signaling a negative outcome. Then the animal can be presented with ambiguous and often intermediate stimuli, and its responses to those are scored as optimistic or pessimistic. So we essentially used a spatial discrimination paradigm where a row of 5 equally spaced goal boxes at one end of an open arena was used to provide spatial cues to the pig. So the goal boxes at either end of the row, which is numbers 1 and 5, served as either a positive cue signaling a food reward or a negative cue signaling the absence of food. So here you can see an up-close view of our goal boxes, and as you can see, it has 2 lids which can open and close. Now the top lid of the box was used as a visual sign to signal to the pig which goal box is active during a trial. So each sow was trained to approach an open positive goal box and to not approach an open negative goal box. And the bottom lid here could be locked and unlocked by the experimenter during trials, so that during a positive trial, the pig could open this lid to gain access to food, whereas during negative trials, the lid was locked so that the food was inaccessible. So after the sows completed discrimination training, the 3 intermediate goal boxes were used as ambiguous cues during judgment bias testing. And a sow's response to an open goal box at one of these intermediate locations was scored as indicative of her judgment bias. For example, if she approached an open, ambiguous goal box, this was scored as an optimistic response reflecting an expectation of the food reward. Now, what I've described so far is a basic go, no-go task design, where a pig either moves towards a goal box or waits for a next trial to start. However, we applied several adjustments to increase the ease of training for the pigs, as they are notoriously terrible at waiting for anything. Therefore, our task incorporated active trial initiation, which means the pigs themselves were responsible for starting a next trial. And they could do this by ringing a bell hanging in the arena opposite the goal boxes. So for a correct go response during a positive trial, the pig had to approach the goal box, eat the food, and then return to the bell. For a correct no-go response during a negative trial, the pig could either wait for the trial to time out, making sure not to approach the goal box, or it could immediately initiate a new trial by ringing the bell. This eliminated the need for waiting and also ensured pigs were actively engaged in the task. Now, for the animals used in our study, these were 15 parity 0 sows, and all sows were 5 weeks pregnant at the start of judgment bias training. They were group housed in a single herd comprising of approximately 65 animals total at any time. The herd was managed as a dynamic group, with some sows being removed from the group to go to farrowing and others being reintroduced after weaning every other week. Finally, all sows were fed by means of a single electronic sow feeding station. So moving on to our results, this table provides an overview of the duration of different steps in the training process. For example, training the pigs to ring the bell and then approach a goal box required on average 3 training sessions, while actual discrimination training, where the pigs had to learn to perform correct go or no-go responses, required about 4 sessions. Together, the total training process took 8 to 13 sessions, with each session containing up to 40 trials and lasting approximately 15 minutes. What's more, all sows that were enrolled in the study managed to successfully complete training, suggesting learner bias does not have to be a limiting factor of judgment bias tasks. So moving on to the results from judgment bias testing. This graph shows the effect of Q-type on optimistic responding averaged across 6 test sessions. On the x-axis, we have the different Q-types ranging from negative to ambiguous to positive. And on the y-axis, we have the optimistic choice percentage, meaning the percentage of trials that pigs made a go response. As you can see, there is a gradual increase in optimistic responding from negative to ambiguous to positive cues. And this result was statistically confirmed. This response gradient shows our animals successfully discriminated between the different cues. And also, the error bars indicate we managed to capture some individual variation in judgment bias between the different sows. And just to give you a better idea of this individual variation in judgment bias, these are 4 examples of individual response curves. Now, as you can see, these individual pigs, which were housed in the same environment, responded quite differently from one another. In fact, when we average optimistic responding across the different ambiguous cues, we captured a range in optimistic choice percentage of 33.5% to 72.5%. meaning some pigs were on average pessimistic, whereas others were on average quite optimistic, approaching the goal box for the majority of ambiguous trials. These findings suggest that our judgment bias task is at least sensitive enough to detect differences in optimism. Currently, we're investigating whether different social measures could be, at least in part, responsible for these differences between individual sows. In conclusion, I am happy to report that we successfully implemented a judgment bias task for sows, with discrimination training being relatively efficient and also highly successful. I'm hopeful that future studies will continue to provide more detailed information on their training process, as this greatly impacts the usability of a judgment bias task. Not only are more extensive training durations more time-consuming, but longer training times also pose the risk that a pig's participation in a study may affect its emotional state through cognitive enrichment. I want to end my talk by highlighting some of our ongoing work, which includes analysis of a variety of social measures to explore whether these are a potential confounding influence when assessing judgment bias in group-housed animals. For example, feed order, which is the daily order in which sows enter a feed station, has been reported as a measure of social rank in several studies. We have found that feed order did not affect judgment bias for our sows. Currently, we're adding analysis on additional measures reflecting both negative and positive social interactions, such as skin lesions and affiliation at rest. That brings me to the end of
Thank you very much, Sanne. I left a little pause there because people said that we've been cutting off the end. We're now in the position. Hello, hi, good to see you. For Sanne to be answering some questions, and we've got some through. So, are you ready to go?
Yep.
Great. Eamon Azadan says, many thanks for the valuable presentation. I have two questions. As far as I know, pigs' ability to discriminate colour and shapes, visual cues, are well developed. But how about other cue types, such as olfactory or auditory cues? Do you think these cue types are as effective as spatial visual cues for judgment bias tasks in pigs? And my other question is there any chance to measure both valence, positive and negative, and arousal, low and high, of pigs' emotions with judgment bias tasks?
Those are both excellent questions. As for the different cue types, it is true that they can deal with many of them. I have found them to be quite different in how successful they are. So I've also done some work using auditory cues with pigs. That was actually the example in the slide that took forever for the pigs to learn, which we suspected had something to do with they seem not to be as engaged in the task. Like, we didn't know if they were paying attention or not. And so that was a big down point of using the auditory cues. As for olfactory cues, yes, they would be excellent at that. Similar with also tactile cues, I imagine they would also be really good at. Difficulty there is establishing whether they experience it as two extremes, and also intermediate cues as well with olfactory cues that can be a little different because we don't really know for sure how they would experience those cues. So I imagine that would be a tricky point there. As for also measuring arousal, I have no experience in that. I think what's great about judgment bias is that it allows for that differentiation in difference in valence, but it does not necessarily state whether that within that valence, whether the arousal states differ. So there's not much info I can give on that.
Question from Catherine Cronin. very excited about the addition of the active trial ending option, the bell. Can you talk a bit more about how often sows use the bell, whether you think including the bell option was key to your results?
Absolutely. So I would say ringing the bell 99% of the time. I had maybe 2 pigs that did less than a handful of actual no-go responses. So I think this, especially working with pigs, like I said, getting a pig to wait for anything is near impossible. This way, they're more in control and they don't have to sort of withhold themselves from doing something. And I think that was a key ingredient to making this very successful, yes.
Benjamin Lacour says, very interesting talk, thanks. Any data regarding habituation to ambiguous cues? We've found calves to quickly habituate in spatial learning tasks.
Yeah, that's a huge issue. So I have analyzed it and it seems like it's not an issue. So I analyzed for a cue by test interaction, because the expectation there would be, as pigs learn, in our case, we rewarded everything as expected. So as testing progresses, it is possible that the pigs learn once they approach a box that there's a reward there, they could continue to do so. We found no effect of testing session. And I think part of this was that the ambiguous cues are really drowned out by a high number of positive and negative cues. So we used 40 standard trials with either positive or negative, and then interspersed in that only 3 ambiguous ones per session. So the downside of that is that it is more time consuming for a session to finish. But the plus was that we managed to avoid pigs learning about the outcome of the ambiguous cues.
Thank you. Question from Moira Harris. Are you sure that feed order in a large dynamic group is an accurate reflection of social order?
No, we weren't. I saw it used in multiple studies. Some other work going on with the same group also cast some doubt on that. And so that's part of why I wanted to include it, to see, is it any sort of indication of, also to include with other social measures. So we will be looking at correlation. So far, it's not correlating. Obviously, it's a very easy one to use because data collection is instantaneous once you have the data. But no, I don't think it's an entirely accurate reflection. I do think there's something there. We definitely see that the bigger, more experienced animals are the ones that feed very early, whereas animals that are new to the group are the ones that start at the bottom. But it's not quite as simple as that is an entire reflection of social rank.
Question, was the training enriching for the pessimistic sows, or was it potentially stressful for them versus the optimistic sows who may have found the training fun and enriching?
Both could be possible. I work with the pigs in a way that I try to avoid the stress. So you can tell when a pig is stressed. And so the way we worked was, let's eliminate at least the stressful aspect of it by making sure that if they needed more time in a certain step, then that's what they got. But it is very possible that obviously some pigs are going to be more scared of novel situations than others, and also the enrichment aspect is huge, I believe, which is why our focus on training duration, one of the main reasons was that a long training time is very enriching. And we did see that the sows that I was training were waiting for me at the gate, because they were all in the main pen, and so they would know when they got to train. So clearly they were quite keen to do it. So yeah, cognitive enrichment is a big potential issue, yes.
Another question. Amongst the negative responses in the judgment bias task, which were most active, ring the bell or passive wait, i.e. no go? Did this percentage, okay, and it said, did this percentage or the latency to ring the bell differ according to the stimulus? Negative, ambiguous, mid, etc.
So ringing the bell was pretty much all that happened. As for ambiguous cue, I have not seen the sort of classic no-go responses. So in terms of latency, I can't say anything about that because ringing the bell very quickly became their go-to negative response.
Okay, great. And we have, well, we've got one more question here, but more can come through. Great talk, very interesting study. This person said, sorry if you've explained the thing she's asking, because she had a minor computer issue halfway through your presentation. But she said, did you consider that the dynamic group sows, the way they were kept, may have influenced the stability of their hierarchy?
Yes, so that is possible. I used the dominance measures that we used were all reflecting about 2 weeks prior to avoid any major changes in the hierarchy, because that is a risk of a dynamic group, that if you want any social measures reflected over a longer period of time, those are going to be quite unstable because the group is changing regularly. So in our case, it changed every 2 weeks. And so I chose 2 weeks as a sort of a maximum period that the social measures could reflect, just to get that stability.
Excellent. Okay. Well, thank you very much, Sanne. I think we'll now move on to the next presentation and part of the program. So thank you.
Thank you.
Thanks. So the next part of the conference, we're moving through to the UFAW award presentation, of which there are two. The Young Animal Welfare Scientist of excuse me, sorry, the UFAW Awards. I'm sorry about this. I'll just slow down and let it catch up. And one more. Right, so thank you. So we're moving on to the UFAW Awards, which we're looking at the Medal for Outstanding Contributions to Animal Welfare Science and the Young Animal Welfare Scientist of the Year. So Hugh, do you want to turn on your camera and your microphone, please, for this?
Hopefully you can see me now. Thanks, Steve. I hope you're all enjoying the meeting and working through any technical issues. Sorry if you've had any issues, but I think most people have got them sorted out now. So it's my pleasure to do one of the most fun parts of these meetings, which is to announce our award winners. So for those of you who don't know, UFAW awards a medal for outstanding contributions to animal welfare science, which is not quite a lifetime award, but almost, and also a Young Animal Welfare Scientist of the Year award for an early career researcher who's made a really big impact within the first few years after their PhD. So if you didn't know about those awards, perhaps you might want to consider nominating someone or even yourself for next year. So do have a look on our website about the awards. But for today, it's my pleasure to announce the winners for this year's awards. And I'm going to start with the Young Animal Welfare Scientist of the Year. We had an exceptionally high standard of nominations this year, several people who we could have easily given the award to, but we did have to narrow it down, and we actually ended up with two people whose contributions we really wanted to recognise. So as well as awarding the Young Animal Welfare Scientist of the Year, we also would like to give a highly commended mention to Dr. Faye Clark from Bristol Zoo, who's done some really fabulous work on cognitive enrichment of zoo animals. She wrote the Bayesian Animal Welfare Toolkit, and she's very involved in teaching animal welfare to the next generation of zoo workers. And she's also a much valued section editor for zoo animals of our journal Animal Welfare. So huge congratulations to Faye. But this year's 2020 Young Animal Welfare Scientist of the Year is Dr. Irene Kamelink from the Polish Academy of Science, as you may have already guessed if you saw that slide about a minute ago. Irene has had a spectacular start to her career. She's published over 40 peer-reviewed papers already, mainly on pig behaviour and particularly the sources of aggression in farmed pigs and potential solutions which improve the welfare of farmed pigs. And not only has she done some really fantastic academic research, she's also been really active in ensuring that her work leads to real-world changes, which is something that UFAW is always incredibly keen to encourage. And she's done that by both trying to understand the attitudes of farmers to welfare and the barriers to change, but also disseminating her work and the work of others to pig producers and the livestock industry so that they can implement some of these improvements. We'll be hearing about some of Irene's work in her presentation in the session tomorrow morning, but for now I'd just like to congratulate Irene, and if she's there and she can turn her camera on, ask her to say a few words. Hopefully Irene's out there somewhere.
I'm just checking. I've asked her to turn it on. We'll see if it comes through. Irene, are you there?
The internet gremlins are out there again just to raise.
It seems she's offline actually at the moment, so that's a pity.
We can congratulate Irene tomorrow morning when she does her talk. So if we can't get hold of her today.
Yes. Okay. So she was. We did check before the session started, and she was available then, but doesn't seem to be available now. For which many apologies. So I guess we move on to the next award, where there's a lot of people who are getting a bit anxious, Hugh, looking at the question.
Yes, I'm sorry. We played about with the order of the talks here, and you might be able to guess why. So next, it's my pleasure to award the UFAW Medal for Outstanding Contribution to Animal Welfare Science, and perhaps unsurprisingly to some of you, the winner is Professor Dan Weary from the Animal Welfare Programme at the University of British Columbia. I'm sure almost all of you know Dan or know of his work. Much like Irene, he's got a really spectacular scientific record of 260 peer-reviewed papers, which one of the people who nominated Dan described as one of the most inspiring and influential scholars in the field of animal welfare science. But equally importantly, Dan has also been incredibly involved in disseminating that into real-world change. So Dan's career has been based around largely using animal behavior and other non-invasive measures to try and assess animal well-being. And he's done all sorts of work, a huge amount in the livestock sector, but in other sectors like lab animals too, to understand what's important to animals or what might indicate that they have poor welfare. And just as a couple of examples, his work validating indicators of hunger in dairy calves has led to them being fed to satiety rather than being left hungry as the sort of industry standard. And his work on disbudding and the potential pain involved with that has meant that animals are often now provided with analgesia or local anesthesia when they're disbudded. And something dear to my heart, Dan's been really involved in trying to understand the welfare impacts of killing lab rodents with carbon dioxide and advocating for doing it in a better way. And that's a real common theme of Dan's work, that he sees a better world out there where we can put this science into practice and do something better than what we do now. And he's worked with the people who work with these animals to convince them of that, not sort of hectoring them, but just very gently persuading people that there's a better way of doing things. And that's a big part of why we'd like to recognise Dan's achievements. But there are a couple of other things that I'd like to pull out too. Dan also is incredibly good at nurturing students and young researchers, as is everyone at that group out at Vancouver. and it's very hard to go very far in the field of animal welfare science or animal welfare advocacy, or even speaking to government policymakers without meeting someone who's trained out at UBC, or who's at least been out to visit for a couple of weeks and been inspired, and I'll include myself in that list. And finally, Dan also travels the world doing that kind of advocacy, teaching and advocating for animal welfare. It's quite hard to actually track him down in Vancouver unless there's a lockdown. And that's another thing that UFAW really values, is taking the message out to those who perhaps don't hear it as often as some of us do. So taken together, I can't think of a more worthy winner than Dan. So huge congratulations, Dan. It's a pleasure to have you here. I'm not sure if your medal made it to Vancouver yet, but if it did, I would virtually hand it to you.
So Dan, do you want to turn your mic on too, so we can hear you? There we go. You're still muted. Try again. Oh, shall I try and turn you on from here? 2 seconds.
I really do think we should measure Steve's cortisol levels before and after one of these meetings.
Okay, so no, you should be unmuted. So I've just sent you a request to do it. Hopefully, I know that we had, depending on which computer, sometimes these requests come out. So if you click on that, does that come through? I'm afraid I can't take control to turn you on, Dan. Ah, okay. We're going to have to look at this because we want you to answer questions after your talk too.
Okay, but we're doing Dan's talk as a recording, so that'll give us 15 minutes to work on the tech, I guess. So in that case, I will introduce Dan's talk, which is, as some of you may have already read, a Bayesian conception of animal welfare. So you had a bit of prior information there. So hopefully, Steve, we can play the recording and then get Dan back online to answer questions and accept his award.
I have everything crossed. We can do that. Okay, I'm going to play the video now. So here we go.
Hello, what a great pleasure to be with you today. And thanks very much to UFAW and to the organizers, and especially to Hugh and Stephen for inviting me here today, and for this opportunity to talk about what I think is this very interesting idea, and I'm really looking forward to the opportunity of sharing that with you and getting your feedback in the question period. As a teacher at the University of British Columbia, one of the courses I teach, I talk about science communication, and in that element, one of the things that I talk to the students about is the importance of having a good hook. Basically, being able to draw the listener in to your presentation with this with a good hook. And so I thought a little bit about this here, and my hook for today's talk is, this talk is all about probabilities. Okay, maybe that's not such a great hook for those of you that are really into probability theory, but I do hope to convince you that this thinking about probabilities and thinking specifically about Bayesian probabilities can transform the way we think about animal welfare, can make us recognize, I think, the importance of some old literature and make us refocus on some new literature and new ideas around animal welfare. And I think it also sets the stage to ask questions about welfare harms, which I think have not been properly considered, and also points to areas for new research. So that's my hope for today. But before we get any further, I wanted to also just tell you a little bit about who I am. And in doing so, one important element is to talk about how my research is funded. For the past 25 years or so, I've been funded mostly by this organization, Canada's Natural Sciences and Engineering Research Council. And that organization has basically matched the funding that's come from, mostly from the dairy industry. So partly provided by the dairy farmers themselves, but also by allied industries. And it's important to say that for a couple of reasons, but I think most importantly in today's context is that even though I'm talking about quite a theoretical concept, ultimately I want my work to be applicable. I want to be able to apply it to improve the lives of animals and to also improve the lives of those people who care for animals, including farmers. Okay, I promised you I would talk about probability, and what better way of doing it than starting off with a coin toss. And because I can't be there in person, I've got this cheesy video of me tossing a coin. So here goes. So flip the coin down, there it goes, beautiful. And try to catch it. Yes, he gets it, good. And then with a flourish, what's it gonna be, Dan? Heads or tails? Let's see the result of that coin toss. Ah, it's a tail. Here's a shiny Canadian penny with a beautiful maple leaf on the side. And at this point, maybe some of you are thinking back to your grade 7 math class or whenever it was that you were first introduced to probability theory. And I'm sure your teacher explained to you that, of course, if you hadn't already worked it out, the chance if you flip a coin is the chance that it comes up tails is going to be 50% or 0.5. So let's keep on flipping that coin. I won't subject you to the video each time, so you just have to go along with me in this beautiful PowerPoint animation. Then I flip the coin a second time, and you can see, as chance would have it, I've come up with a second tail, and a third time, and a fourth time, and a fifth time. My goodness, am I on a roll, right? So you get the idea here is this sequence of events. And even though the chance of just one tail is 50-50, if the chance of getting a number of tails in a row becomes quite rare. So in fact, it's going to be 0.5 times 0.5, that's a quarter, times 0.5, that's an eighth, times 0.5, a 16th, times 0.5, that's 1 over 32. Or another way of expressing that is around 0.03. So if the chance of getting 5 tails is 0.03, then the inverse of that is going to be about 0.96, right? So at this point, you look at this, you say, oh, that's pretty small probability, Dan. So maybe you're not throwing a fair coin. Maybe my coin doesn't have a head and a tail as we would normally expect, but rather has 2 tails, right? If I had one of these 2-tailed coins, then every time I flip it, it's going to come up tails. And so the chance of 5 tails in a row, well, that's 1, right? So at this point, you're looking at this probability pretty small, this probability is pretty big, and you're thinking, oh, well, maybe if you're a conventional, if you're thinking about probability in a conventional way, you might think that this is an unlikely outcome relative to this. But what the Bayesian would say is, no, you don't just consider the new data. Consider the new data in context of your prior expectations. What are your expectations going into this? In other words, before I showed you the result of even the first coin toss, what do you think the probability was that I had in my hand a normal 2-sided penny or this relatively abnormal 2-tailed penny? And let's say, so that's Bayes' rule now, that we're going to consider these prior expectations. That's really that's all there is to it, is we take into account the prior expectations when we look at new data. And in this case, let's say the prior expectations are that the chance of these 2-tailed coins, well, that's 1 in a million. So the chance of getting one of these coins then is this 0.00001 versus this very high probability of it being a normal 2-sided coin. And what Bayes would encourage you to do is now multiply these probabilities. Consider this probability in the context of this larger probability. And when you do that, you see that that number is actually much larger than it is when you look at this very rare outcome, even multiplied by this very high number. So this shows the importance of considering these priors, the prior expectations, in terms of evaluating current data. And what I'm going to talk to you about today is that this isn't just an important concept in probability theory. This is an important concept in animal cognition. I think it has really important ways in terms of how we should be looking at animal welfare. So let's switch to an animal example for those of you that are more interested in animals than in probability theory. And here we have two individuals in our group, two researchers in our group, Julia and Amandine, and they're pushing this somewhat reluctant heifer into this chute here, as you can see. And a conventional animal welfare approach to this issue would be to let's ask about the cow's experience and ask how that experience is informed by the kinds of things that are happening to it in the moment, its current sensory input. But you'll see immediately from what I've talked about earlier in terms of the Bayesian perspective is that the animal's appreciation of the current data should actually also be informed by its expectations going into the event. So in other words, that we should see the cow's experience as, yes, informed by the current sensory input, but that sensory input is seen in the context of the expectations before any of that data was available. And if we look at a more specific example, then we can think back to Julia and Amandine, and we can say, well, okay, maybe even if the sensory input is relatively neutral, the sights, sounds, smells, etc., are not in themselves harmful or scary or painful, that if the animal went into the procedure expecting that it will be unpleasant, that the animal will experience it as unpleasant. So this is really the power of this Bayesian conception of animal welfare. And here's an example with negative expectations, but what if we turn this on its head and look at an example of positive expectations? And the most obvious example of that is the placebo effect, which of course you all know. And the cool thing about the placebo effect is even though the sensory input is by definition zero, we've given the patient just saline or a sugar pill, so there's no meaningful sensory input. Because the patient expects that, let's say in this case, the pain will hurt less, that the patient does indeed experience less pain. So again, the power of this Bayesian context is it allows us to make sense of phenomena like the placebo effect, which otherwise don't make sense if we just look at it from the perspective of sensory input. Okay, hopefully I've got you interested in this idea that these prior expectations are important and need to be studied and are an important component of animal welfare. And with that in mind, what I want to do is I want to look at it sort of an old idea in the literature and a new idea in the literature and see how both of those are maybe informed and invigorated by this discussion around Bayesian processing. So first, let's start with the old literature. And I'm going to reach way back now into the beginnings of the literature in experimental psychology and this classic experiment by Watson and Rayner on little Albert. And little Albert was actually a 9-month-old human infant. And as you'll see, from our modern perspectives around research ethics, this is sort of a cringeworthy experiment, but it taught us a couple of interesting things that I'll get to in a minute. So what Watson and Rayner did is they basically conditioned this 9-month-old boy to fear rats. The way they did that is they started off and they would show young Albert a rat, but also a bunch of other stimuli, which Albert didn't show any fear response to. In fact, some of them, like the rat, seemed quite interested in. But what they did is subsequently, every time they showed Albert that rat, they had this sort of long metal bar in the room and they would bang that with a hammer. And that made a horrible sort of clanging, banging sound that Albert was, surprisingly enough, very scared of and found quite distressing. And as you can imagine, is over a number of pairings, Albert began to fear the presentation of the rat. So this is fear conditioning, right? Is that initially the stimulus is not fearful, but it's paired with something that is fearful. And then basically the stimulus themselves now, in this case, the rat, becomes fear-inducing for young Albert. The other really interesting result from this study was they also found that Albert generalized that fear. So now all of a sudden Albert was not only afraid of the white rat, he was afraid of other sort of small furry animals. He was even afraid when the experimenters put on this sort of Santa Claus, this white beard. This process then is known now as stimulus generalization, that animals and people respond not just to the exact stimuli they were trained with, but also a range of similar stimuli. This aspect of fear conditioning and stimulus generalization together, I think they can have really important and often negative effects on the kinds of experiences that animals have. So let's go back to Julia and Amandine now with that, our heifer. And now we've come to realize that, of course, this heifer is this powerful Bayesian processor, right? So it's taking into account the prior experiences and its expectations, basically, very much informing its current experience. And so in this case, let's say that it's learned to associate maybe Julia and Amandine with something fearful or painful in the past, or maybe it's associated this shoot with something painful or unpleasant in the past, or maybe simply the animals learn to associate other farm workers that dress similarly or behave similarly as being fear-inducing, and therefore is generalizing that kind of response. Either way, or any way you have it, what you see is that this animal's expectations are very much driving the current responses that you see. So even though the current stimuli may be quite neutral, the animal's responses are negative, and that negativity is being driven by the prior expectations going into this. Okay, that's a negative example, but we can just as easily flip this on its side and show a positive example. And in this case, actually, Julia and Amandine are going to show us just exactly that. So here we have Julia just entering the pen. Amandine's actually off on the side of the video at the left-hand side, a little bit out of our field of view. And right in front of us, we have a beautiful new heifer that, in this case, looks really interested in what Julia is doing, and you'll see why in a second. So I'll start the video. Julia closes the gate and she walks in. You can see the heifer's already running over to be let in. Julia opens the entrance and the heifer runs in to come up and approach the gate. And you can see actually the heifer just getting a little food reward from Julia there, and then approaches freely into the headlock. And so you can see now the power of providing, in this case, positive expectations for the animal. The environmental stimuli are identical, right? The only thing that's different is what the animal's prior expectations are going into this event. Now, this is, I said, this is an old idea, and indeed, this training animals so they have positive expectations for events is well used in some aspects of human interactions with animals. I think the zoo environment gives us a number of good examples. I think it's way underused in many other situations, and I'd say, especially on farms, we've got much more opportunity to really think explicitly about what kinds of expectations are we developing in our animals, and working actively to modify those expectations so they're positive, and so then they therefore experience these otherwise neutral events as being much more positive than would otherwise be the case. I said I'd also discuss a more modern idea, and I want to talk about an idea which I think is actually really important in animal welfare, but I think has been up until now maybe not given due attention, and that is the ideas around effectiveness that Franks and Higgins describe. Franks and Higgins are coming from a background in human psychology and interested in human dimensions of wellness, but in this paper, I think make excellent arguments for how those same conceptions can be applied in terms of our understanding of animal welfare. And they're really talking about three main dimensions of effectiveness. And the first of these, value effectiveness, I think is the one which is easiest for us to recognize as sort of traditional animal welfareists. And that's simply, do you have what you want? Do you have access to a warm bed, to some good food, to social companions you want to be with? So this is about sort of, from an animal welfare perspective, providing animals things they want. Okay, very passive notion. The second aspect is more active. So this is really relates more closely to ideas around agency, and that is that the animal is able to actually access what it wants. This is what Franks and Higgins call control effectiveness. And this most simply can be thought of is, can the animal, is the animal able to approach the things it wants and to avoid the things it doesn't want, to seek out opportunities basically for good things and to avoid opportunities for bad things. These two concepts fit very nicely within sort of the simple traditional conceptions, sort of the pre-Bayesian model that I showed you earlier, that the animal's responding to simply to the sensory inputs. There's good things, the animal's experience is good, and it goes towards those good things. It's the third component of effectiveness, though, that stretches this. So, and that aspect is called, they call truth effectiveness, and that's about the animal's motivation to learn about its environment, its physical environment and its social environment. And to make sense of that, I think we really need to go to this more Bayesian conception, because this is all really about developing a set of expectations. How do animals learn about the world so they know what to expect? How do they essentially experiment with the world to know what's good and bad? And if you go back to these conceptions of around effectiveness of Franks and Higgins, if you think about it, what you can see is that the entire idea of control effectiveness is sort of a sham if you don't know about the options. You need the truth effectiveness. You need to be able to learn about your environments in order to know what to approach and what to avoid. And I think from that perspective, it really underlines the importance of really thinking about how do animals develop expectations about the world. And I think in a more troubling way is what happens also when the animals are unable to do that. And this, I think, introduces a different type of welfare harm, which is, well, what happens when animals aren't able either to learn about the world or aren't able to access meaningful memories, aren't able to access their prior expectations in order to make good decisions. And I think there's things that we do in animal handling situations in farms and in labs, which do sort of blind animals to these expectations, and that can have important welfare consequences, which I think have been under-investigated. Okay, I said I'd leave you with a few ideas around specific kinds of studies that we could do if we were to become Bayesian researchers. So I wanted to just end off with those. And so one and most obviously from the way I started off is that we need to, as animal welfareists, move beyond just considering stimuli that the animal is currently exposed to, and also consider how the animal's experience is affected by its expectations. So, for example, Benjamin Lacour, a senior PhD student in our group, has just done some beautiful work where he looked at how animals are responding to painful experiences and found out that animals that are more pessimistic, in other words, animals that have negative expectations going into the experiment, tend to show stronger pain responses. So that's definitely consistent with that idea. A second type of issue, I think, is that we need to study how expectations are developed and how this development could be manipulated to improve welfare. I discussed already one nice example of that, which is Julia Loam's beautiful work in terms of training heifers to have more positive expectations of a situation and how that can really dramatically affect how they respond to a otherwise innocuous event. A third example I'd like to talk about is how we need to do a better job in terms of explicitly understanding this motivation to learn about the physical environment and social environment. And also, I would say, also understand the welfare harms associated with conditions that prevent learning or access to the memories. And I think that's might be a really an under-researched and understood welfare problem, which I hope we can get to in the years to come. I'd like to just finish by thanking very much my colleagues within the University of British Columbia's Animal Welfare Program who've helped in the development of these ideas, and also, of course, to UFAW for the opportunity to be here with you today. Thank you.
Thank you very much, Dan. So let's, if you could turn your camera and your mic on. I'm not certain if we've solved it yet. Hooray!
Yes, success.
Success.
Right.
Excellent.
Okay.
Great.
So,
okay.
do we want to take the questions for Dan while the talk's still fresh in his mind? I guess maybe Steve.
Yes, absolutely. First question we have for an excellent talk, Dan, was, can the Bayesian rule be used, for instance, in a novel tank test in fish, where the fish is introduced to a completely novel environment with no prior expectation?
That's a super interesting question. One of the things that I think that this thinking like a Bayesian, one of the sort of scary things about it is it makes you realize, I think, these different kinds of welfare harms that at least I hadn't thought about properly before. And in that kind of situation where, and I think we often do this with, for example, situations of animal transport, regrouping, etc., we put animals into totally a totally new situation for which they don't actually have any priors. And if you accept the notion that I tried to lay out, that actually this is having access, having well-developed priors through which you can interpret new information is very important to the animal, then essentially when we put animals in a situation like that, we're blinding them to a very important source of context, basically. And that in itself, not only is it might be instrumentally harmful in the sense that it makes it difficult for them to make sensible decisions because they don't have access to any good priors, it may actually also be inherently distressing to the animals, because the animals are, again, accepting my contention here, if you see these animals, sort of these powerful Bayesian processors, then if you blind them in a Bayesian sense, so you don't give them access to any prior information, that in itself could be distressing. And I think that really comes back. I mean, I admit that I mean, I don't have a lot of good evidence to show for that, but I guess that's the kind of thing that worries me when I go down this line of thinking, is that we do this all the time with our animals. We put them in situations where we either prevent them from accessing information about prior expectations, or take away any relevant information that makes their priors useful, and that in itself might be inherently distressing to the animals.
Thank you. Another question dealing with prior expectation. Have you ever verified if there's a correlation between positive prior expectation and increase in production parameters? I work as a policy advocate for improving welfare of farmed animals, and most of the producers ask if implementing the suggestions presented in animal welfare studies can enhance their business.
Huh. I actually hadn't thought about that too much. Of course, I mean, the production measures are hugely important to farmers. Farmers need to be able to be economically sustainable, as Mariann pointed out in her beautiful presentation at the beginning of this session. That said, the profitability is normally a poor correlate of welfare outcomes. In this case, perhaps there could be something there, though. And so I do think there are issues around the kinds of having animals that thrive in the environments we provide them in. And that's sort of the basis to domestication in a sense. And there could be something about this sort of thriving aspect, which translates through to essentially an animal which has this enters this positive feedback loop. So it generates these positive experiences within that environment, and then therefore comes in with these sort of a positive expectation about the world, and interprets new things that we do to it in a more positive way than would otherwise be the case. So there is this aspect of setting animals up for success. I must say that most of my thinking about that relates to trying to create early experiences for the animals that set them up in such a way, but having a good fit ultimately between the animal and the environment is part of that.
Thank you. Katie says, thank you for this interesting talk. Could you give a practical example to illustrate truth effectiveness or lack thereof?
Yeah, I think actually, again, very work which is just in its infancy really, but there is this new work going on now where people are looking at animals' motivation to learn per se. sort of behavioral ecologists have been doing this for a little bit longer, shall we say, where we know that animals are motivated to sample their environment to find out things about their physical and social environment from a behavioral ecological perspective. And in animal welfare too, we see actually in some cases people looking at whether an animal is willing to, let's say, take risk, for example, in a fish situation, assume some kind of predation risk in order to learn some information about the world. So the way I see it is that actually animals are often showing quite high levels of motivation to learn, and as I pointed out in the presentation, I think that if you take the ideas about agency seriously, you're almost forced into taking these aspects of truth effectiveness seriously, because you can't make a sensible decision. You can't know what to approach and what not to approach. Your ability to act effectively is completely tied to your ability to know about the world. So I think that the truth effectiveness is actually extremely important and an understudied element in animal welfare science.
Thank you. Two people have asked similar questions on this, which they've asked for an example of a system or something that would prevent an animal having access to its memories.
Yeah, so I mean, it's super interesting, and sort of gets into sort of the dark side of these things. There are things we do to animals, and I think the most sort of egregious example is sort of the VII for elephants, this breaking of elephants, where we put animals in situations where we, for example, in this case, take away social partners, disrupt the animal's ability to associate what's going to happen when, and actually, the way I think about it is sort of essentially the very elements that come out of the sort of the torturer's handbook in terms of taking away ultimately the ability for the animal or the person to predict anything at all about what's going to happen next, and taken to its logical extreme, actually, that's even taking away the animal's sense of self or the person's sense of self, and that I think is another way of, I think that too could be translated into this Bayesian aspect of if you have this new data coming in, but you have no context through which to interpret it, that if again, if you accept this contention that we're all Bayesians, then that's perhaps the most distressing thing of all. So it's not actually the data which is necessarily the most harmful, it's the inability to make any sense of it, this rudderless aspect to it, if you will. Now, I think that's quite an extreme example, but I mean, as I mentioned right in response to the very first question, this idea that we might actually all the time and completely unwittingly, for example, when we put animals onto a truck at transport, or when we put them into a new group, we're also robbing them of the ability to make sense of their world. We've taken away the ability to make decisions based on prior expectations.
Okay, so related to this too, Tom Rowland says, interesting talk. How is the Bayesian conception different to concepts of cognitive bias or mood, which essentially posits that prior experiences accumulate some biases, perceptions, and action?
Beautiful. So yes, okay. So the ideas of this Bayesian idea obviously interrelates to any kind of measure we could get which tells us about the animal's priors. And if you accept that measures of bias, as we saw, for example, in the beautiful pig talk, tell us something about the animal's overall sort of sense of expectation at that moment, then that's a way essentially of integrating the animal's perspective on, or is a way for us maybe to give sort of some kind of integrative assessment of the animal's sort of overall assessment of the world. I guess one thing that I thought about in my thinking on this Bayesian perspective is that measure is super interesting, but it is perhaps, at least the way we're thinking about it so far, is maybe a little embryonic, in the sense that the animals are likely much more sophisticated than simply asking questions about my overall mood state in terms of deciding what's the best course of action. So a well-designed Bayesian is taking into account all sorts of contextual information and using that to make decisions on the basis of the new data. And so I guess one question that comes to mind from that is, could we be doing much more sensitive tests of looking at how bias is expressed, depending upon the very specific ways in which we, the very specific context in which we ask that question. So maybe the animals will show positive bias in some types of situations, and of course, the Bayesian would tell you in situations where it makes sense for them to be positive because they've had a positive history, and negative in areas where it's been more negative. And so I think these overall sort of overall conceptions of bias have been useful so far. I think there's other approaches like anhedonia, other ways which we can get at this too. But I'm particularly interested in seeing us move in a more systematic way, looking at making specific predictions which are context dependent.
So one that's going a bit more fundamental perhaps. So what are the most immediate challenges to your mind in developing a mathematical framework to discuss welfare with?
Good, and I mean, I guess I answer that on two levels. So I think mainly why I want to talk about this today is because I see this as a useful sort of conceptual, sort of at the 10,000 foot level. So I don't think we all necessarily need to get into the maths in order to make sense of this. And so, for example, for me, I think the most sobering aspect of thinking about this is I spent most of my career, even sort of embarrassingly in the examples that Hugh brought out, sort of focusing on the here and now. You know, okay, do we give the calf the anesthetic for disbudding, these kinds of things, which of course we should. And of course those are important. But I guess what I increasingly fear is that although those immediate things are important, maybe the much more important things in terms of overall condition for the animal, really the animal's suffering, which I think is sort of the key element of animal welfare, is in the contextual aspects. So we need to really put more effort into. So I mean, in a way, I think I'm using this as this Bayesian framework is just a way of reinforcing the importance of going back and understanding the context and using that as a way of understanding how two animals, and we saw that again in that beautiful pig talk, can be interpreting the same stimuli in very different ways, and then the opportunities for suffering associated with that. So that's one part. That said, I think the math is super cool, and I think one of the attractive things about this whole set of ideas is actually it's quantitative. It's not just qualitative. It offers the opportunity to really develop quantitative models as well, and I think that is exciting. And again, completely underused. So we would be foolish, I think, not to take advantage of some of those more quantitative aspects. And there's certainly lots of opportunities to do that with this approach.
So one final question. I'll send you the other ones too that people have asked. So how do contrast effects, cases where expectations are violated, fit into this model, i.e. a positive expectation, large reward, combined with a less positive action result, small reward, can result in a negative emotion?
Beautiful. So I mean, of course, I could have used those kinds of contrast effects as one of the examples of how, without a Bayesian perspective, this is why I suspect we're all closet Bayesians, is we could never make sense of something like a contrast effect, right? The animal obviously needs to be taken into data and put it into context of what its expectations are. And that is the way of making sense of it. So no, this is the Bayesian reasoning provides a theoretical context through which we can make sense of some of these sort of phenomena, which I think are otherwise seen as spooky science things like placebo effects, things like these contrast effects, which otherwise is, oh, why does the animal, value 5 grams of sugar now, but before it only valued 1 gram or 10 grams? This makes sense if you consider the animal's context, and it doesn't make sense otherwise. Now, I think that, again, we're maybe not taking advantage of the full power of that in terms, and I would say especially in terms of these understanding these unintended negative consequences of how poor expectations might be making things really dramatically worse for animals. But the opposite holds too.
Thank you. Fantastic talk and great set of answers too. And congratulations again on getting the UFAW medal. Very, very well deserved. I don't know if you want to say any words at this point, or sorry about the microphone.
Not at all. Absolutely. So thank you very much again, Hugh and Stephen, for this award. Real honor and a pleasure. And I guess I'd just like to really thank especially the students and postdocs and all the people, my collaborators over the years that have been, of course, couldn't have done any of this without them. And I'm also extremely grateful to my colleagues within the Animal Welfare Program, David Fraser and Nina von Kaiserlink as well, of course. More recently, we now have Sasha and my other colleagues within our group, Ronaldo, etc. So really, this is a team effort and very much a pleasure working with all these sort of smart, dynamic individuals that keep me challenged.
Thank you, Dan. Thanks very much. So, Hugh, we've got to the end of the first day, end of session 2. There's a few things I just quickly want to share. The first is, if you've enjoyed this meeting, then we have another meeting coming up in Edinburgh in next year, which is the 29th and 30th of June, and it's on emerging challenges and solutions. So we're hoping it's going to take place at the Royal College of Physicians, and we'd very much like to see you there. And also, just to highlight again, if you've not looked at it, that there is a discount for the Wiley-Blackwell books that you can download as the handout. And I will leave the final words to UFAW's Chief Executive Officer and Scientific Director, Hugh Golledge.
Thank you very much. Thank you all for coming. Congratulations again to Dan and Irene and Faye. I think we've learned a bit today about what Dan was talking about, that unpredictability is quite stressful, but I hope everyone got through the meeting more or less unscathed. And we're really looking forward to seeing you tomorrow for the second half of the meeting. Have a great evening. I'm sorry we can't do what we'd usually do at one of these conferences and have a drink with everyone and a chat, but we look forward to seeing you again tomorrow morning. Thanks very much.